So I'm delighted to introduce this next session, which is moderated and hosted really by the Water Council of Milwaukee. And just to put this session in perspective, I think as most of you know, FLC undertook technology focus areas a couple years ago in which they pick a topic of national interest and in which the labs are engaged in technologies that could contribute to that interest. And so water is certainly a critical resource, and that was the initial topic a couple years ago. And so today's session is really to get an industry perspective on water-related technologies and hopefully how the federal labs can assist in solving some of those technical needs and challenges. We realized very early after starting this initiative that we needed a much closer tie to industry, and realized the ideal mechanism to do that was through an organization like the Water Council, which is a member-based organization with industries related to water technologies being members. So rather than us trying to reach out to a myriad of individual industries, it's ideal if we could work through an entity like the Water Council who has water-related technology industry members. And so that is what we've done, and it's been a tremendous relationship, I think, and one that we are on the cusp of really leveraging. There's still so much more opportunity here, I think. I want to give recognition to Jim Zarzycki, one of my NAC, National Advisory Council colleagues, because Jim is really the person through a series of events of finding the Water Council, establishing the relationship and nurturing that relationship on behalf of FLC. And I think the Water Council, I think I can say, holds Jim in very high esteem. And the proof of that is he was invited to join their board of directors recently, and I think he's probably attended his first board meeting. And if that's not a testimony to the value that that organization places in Jim, then I don't know what is. So, Jim, I just want to acknowledge your role and thank you for that. At this time, I'd like to introduce Karen Frost, who's the Vice President of Economic Development for the Water Council, and she has put together this panel of representatives, and she will facilitate the panel proceedings. Karen has a lot of experience in program management and grant management, marketing, and she's been especially powerful in forging a relationship with small business and the water community. So I'll ask Karen to introduce the rest of the panel members, but would you help me welcome Karen and the Water Council to the stage here?
Well, thank you so much for being here this afternoon. It looks like we, excuse me, lost a few people after lunch, but hopefully we'll gain a few more participants. But thank you so much for the opportunity to be a part of the panel this afternoon. It really has been a very evolving relationship with the Federal Laboratory Consortium and the National Advisory Committee, and one that I think, you know, as Dick mentioned, is really still advancing. And I think, you know, we said it was kind of in its infancy before, and now it's in its toddlerhood, but I think that there's so much more to be done, and we're very much behind, you know, continuing and building on that relationship and exploring what further ways of collaboration. So I'm just going to give a very brief introduction of the Water Council. I want to introduce my panel members, and then come back to and give a little bit more information on who the council is and kind of how this, how the relationship actually evolved. So I'll introduce Jim Zarzycki, and then we have 3 industry members, and I'll let each one of them introduce themselves, what they do for their organizations, and what their company does in terms of water technology. So, Jim?
Well, probably enough been said about me already. So I am a former laboratory director within the Department of Defense, and when I retired, I was asked to be on the National Advisory Council, and I've been lucky enough to find this niche of being able to work with the Water Council.
Cameron Manners. I'm the CTO of Aquam Corporation and former CEO and one of the founders of the business. We've got offices in the UK and in the US and Canada. We manufacture certain different products have used some of the laboratories that you guys will know when I speak a little bit about that. We do a lot of different technologies. We use robotics for the diagnostics of assets inside city municipal water systems, as well as closed-loop systems. We can determine the life expectancy and remaining life expectancy of those piping systems, giving key data points. We also do a lot of rehabilitation. So we do rehabilitation of lead service lines, which I'm sure everybody's quite aware of, as well as internal building infrastructure systems. So angioplasty for buildings, if you think of it that way, kind of without ripping anything out and not moving anybody out of the building, which is pretty key. And we also do a lot of data management for a lot of the water utilities in the UK. So we manage the interaction when you need to take water off the system in the UK, Thames Water, Yorkshire Water, places like that. We manage the interaction of the billing and supplying of the meter system that the contractors will use to do that. So we do that pretty heavily in the UK, and we're now expanding that technology out into Europe.
Okay, so Joe Gifford, responsible for RD&E, Research Development and Engineering at Evoqua Water Technologies. We are a global company, although most of our business is in the US. We do everything from municipal water treatment to industrial, process water and wastewater and industrial as well. So we're a bit, I'd say, diverse within the water space. We're not focused on products or service or even systems. We do everything, a little bit of everything. We don't really get into municipal operations. That's the one space we stay out of. So in the municipal space, it's more product-based. Therefore, our research is around products, but also a lot around solutions. How do we solve customer problems, combining and applying technologies? So I guess that's about it.
My name is Matt Stuyvenberg, and I'm Director of Engineering at Badger Meter. Badger Meter is a company with about $400 million in revenue, a global company with 1,600 employees internationally. We specialize in metering mostly, metering and flow control, and we're North America's leading utility water meter manufacturer. About 70% of our revenues do come from some sort of utility, municipal, residential water metering. Another 30% comes from what we call flow instrumentation, where we get into a wide variety of other more exotic applications in pilot plants, process, oil, gas, whatever else. But really our focus is on water. We employ almost every primary measurement technology that is out there as far as metering. I never would have guessed that there were so many when I came to Badger 12 years ago. And then another big piece of it is what we do with regard to getting that information back to the utility and what information we can provide them and analytics we can glean from the data. We really have one of the last pieces of utility infrastructure, of utility-owned infrastructure in the distribution network before it gets into a homeowner's owned piece. So what can we do from a distributed network as far as you've got information all along the distribution line from your trunk meters to your very last endpoint? We're really looking at what else can we provide besides a meter read. Are there other sensors that we can apply into the system to infer non-revenue water, water quality issues, whether that's organics or inorganics, and then presenting that data, the analytics behind it to drive meaningful conclusions for utility. So we're looking into a lot of other sensor applications and then data communications protocols and analytics around that data.
So, good afternoon. My name is Charlie Cooper. I work at the Department of Energy's FLC National Accelerator Lab. I deal primarily with technology development and technology transfer. FLC National Accelerator Lab has about 2,000 people, $400 million annual operating budget. What we do is, like I said, basic discovery science. We try to see how the universe operates. Basically, our biggest push right now is on neutrino science. But in working with particle physics, we develop technologies for particle accelerators in the detector area, high field magnets, and computing, big data sets. We handle a lot of big data sets. Why Fermilab's interacting with the Water Council is one of the technologies that we developed, and particle accelerators has applications in treating contaminants in water, basically.
So thanks to the panelists for all introducing yourselves. I just wanted to come back and give a little bit more context in terms of what the Water Council is and some of the programs that we offer, because many of them and many of the initiatives tie into several of the speakers that you've heard from already today. So we are a nonprofit. We are member-based. As Dick was mentioning, we have about 180 members, but there are about 200 water technology companies in the state of Wisconsin. Many of those industries are legacy industries going, back hundreds of years from the early brewing and tanning industries that were very water-intensive industries in Wisconsin on the shores of the Great Lakes. And so those companies are the companies that made the pumps and the valves and the meters and the pipes and the filters and the materials and that were the suppliers to those water-intensive industries. Companies like Badger Meter and A.O. Smith and many others that not only started there but flourished there. And so we count a number of those very large companies among our member base, as well as many small companies. Companies that are doing smart water applications, that are working in the area of sensors and advanced materials and many other topics. So we actually do categorize all of the member companies that are part of the Water Council among about 13 different classifications that cross 42 different North American industry classification codes. So there is no NAICS code that identifies a company as being water technology. Many of those companies are, have a manufacturing classification or another designation, but we actually have identified about 42 different NAICS codes that make up what we consider water technology. That also includes engineering support services and so on. So that just gives you a bit of context in terms of who is or who we classify as water technology. I wanted to also just share a little bit about what our organization does and how we interact with those members. So one of the programs that we have is we've just closed out our 5th year of an accelerator program. So there was a panel this morning that was talking about accelerator and incubator. We actually have a competitive application for 6 spots in a water technology accelerator program that we run on an annual basis. And like I said, we've just completed our 5th cohort, so we've run about 35 companies that are early stage water practitioners through, a lean startup program and providing them with coaches and mentors and so on to help them advance their technology. We also have a pilot program so that either those companies that have gone post-pilot or post-prototype stage or companies that need to validate technology in the field actually have opportunity to apply for funding to validate their technology in an actual scenario. How we're working with some of our large companies, those that are at the table today, is that we have an upper tier of membership where we work with some of those companies to help them identify emerging technology that could be of particular interest to them and their goals. So our Chief Technology Officer for the Water Council actually works with those companies to identify what their technology focus areas are, and then we try and help them identify companies that meet those criteria. And along the way, introduce them to one another to see where those technology focus areas overlap, and we can actually leverage, evaluating the landscape of opportunities for multiple companies. So that gives you a little bit of idea of some of the programs that we offer. I also work with small businesses. I guess the last connection or just foundation to share is that the first speaker of the day was talking about developing kind of ecosystems or kind of that live, work, play, learn space. And the Water Council is fortunate to be located in the Global Water Center. So we have an accelerator building dedicated to water. So it's a 98,000 square foot building in Milwaukee. There are 43 co-located businesses. Some of those are, offices of our large corporate partners. Some are small businesses. Our accelerator companies incubate in the building. And then we actually have 3 university partners. So 3 different working labs that are in the building that our accelerator companies or our member companies can use, including a clean room and a flow lab and a number of other assets. So just wanted to kind of give the context for the ecosystem, I guess, that the Water Council helps to facilitate for our member companies. I guess with that, I just wanted to launch some questions to our industry partners. Cameron, maybe you can start us out. What maybe is unique with your water technology business in terms of a technology pipeline? Like, how do you source technology, and what are you looking for, or what landscape do you evaluate in terms of sourcing technology and R&D?
Internally, we do a lot of R&D ourselves. The water industry is we were just kind of chatting about it. It's a big industry, but it's actually quite small. So the technology is kind of limited, I find, for us as a company when we go out there and search for things that fit. It's funny as you do start to move around the industry and you start to talk to people. We had a chat today about how Badger's in a space with metering, and we actually have a company that is into metering as well, and we've developed our own technology to suit our application. They have their own technology to suit their application, but they're very, very similar, but we don't cross. So there's a lot of different verticals inside this water industry, and it's an exciting time for us because there is a lot of technology that's needed. But unfortunately, we've gone back to researching a lot of our own stuff. We do a lot of developing ourselves. We have a large R&D facility up in Canada. It's part of our plant that we do a lot of work in. But we also have acquired a lot of technology. So, we've done a lot of acquisitions in the last few years that has really kind of moved our company into the water space. One of them is what we call diagnostics, Aquam Pipe Diagnostics, and that was a UK business that was very small but had a very unique technology that we saw would fit some of our other divisions. So we acquired them, and basically we've moved them into an asset assessment program with utilities. So these are robotic cameras that can go through hydrants into live water main systems, and they can determine wall thicknesses and rates of corrosion and flow rates, and we can also give them feedback and data on remaining life expectancy of their piping systems. So these are all key data points that really, it compounds the problem of the industry where they do things and they spend money, they don't have any clue what they're replacing or how they're doing it. So when you have a budget cycle that is governed by run to failure mentality, you're not spending your money properly. So the technology that we're searching for is like that. The diagnostic side fits into that as well very nicely. And then on the rehab side, a portion of our business is on the rehab side, and we do a lot of research on that. We have many patents on that. I've used NRL heavily for that, which I'll go in a little bit later. So we do a lot of research and development on our own equipment, just simply because it's such a unique business and it's such a unique industry that, there's not a lot of things coming out. And again, I think we're going to touch base on that, but I think a lot of funding needs to happen in the water space and for R&D. And I'd love to see a lot of the labs kind of focusing more on water and on the infrastructure that obviously there's a big hole in funding on. And then on the other side is our metering side. We've gone and developed our own because we couldn't find a small enough meter to go on our standpipes in the UK. And we also developed our own software programs to where we manage the interaction between the contractors and the water utilities. And then we also handle all of the billing that goes out to all the contractors, and they end up paying us, and we keep our portion and pay off Thames and Yorkshire Water. So a lot of the R&D, I guess to answer the question, we do internally, but we also have acquired a lot of technology through acquisition.
Okay. What about Joe? Joe, do you all do a lot of your own internal R&D? Can you kind of run through what your R&D and how you go about looking at technology?
Yeah, sure. So I think Cameron wrapped up with the fact that a lot of it comes through acquisition. I think we're the same way, actually, today. I've been with this company in previous versions of it for quite a while, over 20 years. And it used to be that we had a need, we had a gap, and we would develop it. And the R&D group was bigger and this and that. And over the years, especially in the last few years, realizing that the water business, it isn't really adept to new technology. You're not going to come in with a new mousetrap and get it and make money with it in the next 5, 10 years. Maybe it's 15, 20 years. And we've actually done that. We have technologies that I was working on 15 years ago that are now starting to pay dividends. And so to start from scratch now internally is just pretty much a no-go. Excuse me. So we're heavily interested in external technology. Actually, we really just started the first of this year with the Water Council, engaging as a Tier 1 member and leveraging them to make these connections. And that's why we're here, and that's why we're now using them and their CTO and their R&C program to actually help us scout for technology. I would say, you know, I sit and listen to our board meetings, and I hear a lot, we're technology agnostic. That's become kind of a catchphrase now. So what does that mean? To me, it means, well, we can either develop it or we can go get it. It doesn't really matter. Whatever's the right thing to do. Generally, it's go get it, because it's faster than if you start from, you know, internally. So we do a mix of both. I mean, what we do mainly internally now is repackaging, design, development of products, not really from the technology side. And then we also leverage our R&D resources a lot to go out and actually not only scout, but once we find technology, to test it, to go pilot test it. We're getting a lot more into field, being in the field with customers and actually trying to pilot test and demonstrate technology. And that helps us make informed decisions if we're going to go out and license or acquire technology as well. So.
Okay, and how about you, Matt? Maybe you can share Badger's philosophy.
Yeah, and as I listen to both of the other stories, there are a lot of similarities, but from a certain regard, I would say Badger does more development than research. A lot of what we develop at this point is near market ready. So it's not that we're looking all that often on a 5-year to 10-year horizon, but we're looking on okay, what's coming out the next cycle, the next year, and that's where we're doing most of our work. So a lot of it is more on the repackaging or taking something that's already commercially viable and working it towards our needs. So for reference, on our radio technology, a big part of what we do is get the data back to the utility. How we do that, it used to be someone actually came and walked by, read the meter, potentially had to go into the basement. We came out with remote reads on the outside of the house. Then it was walk-by systems with short-range RF. Then it was drive-by systems where you were beaconing out a read at an interval of which you could drive by and pick up the signals. Then it went to fixed network systems where you were broadcasting a longer distance. And we were first to have a widely distributed cellular network where we weren't using any proprietary infrastructure. We had and as we call it, an endpoint that was communicating meter data every day, making a cell phone call, essentially communicating that meter data with no infrastructure for 20 years. So now it's just staying on the front end of that with regard to the next modules, taking the front end of the consumer available, or at least industry available technology to advance that field. But that came out of an acquisition of a California technology startup company, which had roots back to Stanford as well. So although we may not have been doing the advanced research direct, inherently through the acquisition strategy, we did in some ways fund that research. So certainly acquisitions are important. We also recently bought a ultrasonic technology company. Metering has certainly evolved from a traditional old school mechanical device with wear elements, moving parts, to solid state electronic devices. The primary technology of which we see going forward is ultrasonics. So piezo's, time of flight measurement, various other technologies to use, but we bought an ultrasonic technology company, which, while not domestic to the US, was out of Sweden and had roots in Luleå Technical Institute in northern Sweden. So again, a lot of times with regard to our business model, we'll try to de-risk some of the technical investments. As much as we all love being on the front cutting edge of it, when you've got a limited R&D spend, you kind of need to have some fruits and some returns on those investments in the relatively short term in order to continue to fund them. So one of our strategies is to limit some of our direct research, but we have also been working through the Water Council, the Water Equipment Policy, or I'm sorry, what's the P? Blanket on the P?
Policy.
Policy, okay. Yeah. Through WEP and the IUCRC, Industry University, Research Consortium, Collaborative Research, too many letters, sorry. But working through them to fund research through the local universities as well. So some of the partner universities in the Water Council to take a look at some of those technologies that are on the 5- and 10-year roadmap to start really driving a piece of it at least. And that's been somewhat fruitful to at least have our fingers in where we're going on a strict research level. I would, especially after today, like to get more involved in what else might be out there on the federal labs level, though.
So what Matt was referring to, we're all so fond of acronyms. So there's the Water Equipment and Policy Industry University Cooperative Research Center. So it's a massive mouthful.
You can see where I got confused a little in there.
But what that IUCRC is a collaboration between, excuse me, 2 university partners. So University of Wisconsin-Milwaukee and Marquette University are the two research universities that are part of that. There's actually yet another university that, through relationship with the Water Council, we're actually evaluating and exploring bringing Ben Gurion University and their Zuckerberg Institute for Water Research in Israel as the third university partner. And then there's 18 different private industry members who actually pay a participation fee into that IUCRC. It's actually a program that's run as part of the National Science Foundation, and we're one of two water-focused IUCRCs in the country. So we have diverse industry members who are part of that from all over the US, and we hope to expand that to have some international members if the relationship with Ben Gurion University moves forward as well. But what that actually enables the companies like Badger Meter to do, and I know Evoqua has looked at participation, the participation opportunity with IUCRC, is that each of the companies pays an annual fee, and then they get to actually propose projects that the universities then work on in terms of applied research. And if there is IP that's generated as a result of that work, then the companies get to share in a royalty-free relationship with that IP. So I kind of think of that similar to, but not the same as what a CRADA would be. Is that correct? So that's, since our companies are already, used to or familiar with that arrangement, I think that having the relationship with Jim and with the Federal Laboratory Consortium allows us to explore what opportunities there may be with technology going on in the federal labs that could be of interest to our members. The T2 database, T2 toolkit, what is the business 2.0? We've actually integrated that data set into an online database tool that we have called the Global Water Port that allows that data set to be searched against other data sets like SBIR funded research and IP database and so on, to be able to glean insights from the FLC Business 2.0 data set in addition to those other resources as well. So I'll get into that a little bit. But Matt, do you have anything else to add in terms of IUCRC and some of the work that is coming through your partnership with IUCRC and what looks promising coming out of that relationship?
Primarily what we're looking to fund through there right now are our sensor technologies. So there's some water quality sensing that's of particular interest to us. And so I believe right now they're around a TRL4. So it's an interesting relationship. It's one of which, again, it's a little bit from our standpoint of a fishing exercise, but it's also access to the students, the doctoral candidates and the professors as well to have those discussions and see what else they might have beyond that specific project also. A lot of, in my eyes, a lot of research comes down to the relationships, because it may not be that specific sensor that they're working on that might be the end game for us. It might be that there's something else that we haven't even talked about yet that might spawn the next generation of whatever we want them to develop, or concept that they have that may be of interest, maybe not even to us, but another Water Council member. That's where the value comes in, is in just continuing those conversations with people who have access to the facilities, who have access to the time for free thought, instead of being caught up in the middle of a Gantt chart of their development project for the next product release. That we see as beneficial in those relationships.
And Joe, I know that Evoqua was at least looking at joining the IUCRC. I'm not calling you out on that, but were there specific projects of interest that kind of drew you to that potential?
Yeah, no pressure, right? Yeah, we've had some good meetings. Like I said, we really just started Gen 1 with the Water Council, so we've been traditionally kind of internally focused. We're opening up and really trying to accelerate things to market through external partnerships. We've had a couple meetings with the IUCRC. The last time we were out there, we actually spent another day with them and visited some of the campus research projects. And I guess the way it works, you get in there and you get a project kind of really focused on what you want. There's a number of projects. So we listened to a lot of them. Very interesting. I mean, there's some really good research going on. You mentioned the time of flight, flow sensing technology. I thought that was really interesting, and there's some stuff in that space that it's not necessarily applicable to us, so we, weren't ready to jump on it, but we have had some discussion. There's a professor in the Water Council building working on some aeration had worked on some aeration technology and some pump cavitation technology that for us is actually quite interesting. So we're engaging likely later in the year, would try to move forward with something there. So yeah,